Hello, Mr. T here, and we have a tutorial on integration by substitution. I call this part 2. Earlier there's a tutorial that I made on integration by substitution, and today we're going to be introducing some new aspects to integration by substitution. The first time around we kind of used what I'll refer to today as a shortcut method, and the purpose of this tutorial will be to introduce formal substitution. Let's first just refresh what we did the first time around. We would try to organize our integrand into one of these three forms here, either u to the nth times u prime, e to the u times u prime, or u prime over u. And if we were able to get it into one of these formats, we could then apply our integration rule. So if we rewrite our integrand here into a power of n, we can see now that we're trying to match this format here. So we choose what's raised to the power as our u. So if I put down here what our u is, what we did before is we determined the derivative of u prime, and this is the u prime that we need to be in this format. So this is what we need to have. And we have an x here, so we have part of a u prime. So to get that to match, we need to insert by multiplying by a 2 here. Now we've just changed our problem. This no longer matches. So to get it to match our original problem, we can undo that multiplication by out here multiplying by the reciprocal. Because of our properties of integrals, this 1/2 times this 2 gets us back to our original problem. Now we have our u prime and we have our u to the nth, so we can use the appropriate integration rule, which is to add 1 to the exponent and divide by the new exponent. So we add 1 to a half and we get 3/2, and we divide by our new exponent. We can simplify our complex fraction here by turning division of these fractions into multiplication of the reciprocal. So we're going to take 1/2 times 2/3, the reciprocal. So 1/2 times 2/3 is 1/3. And we have completed, and we have our answer. So this was the way we did integration by substitution our first time around. Let's look at a different problem to introduce a need for something else. So if we look at this problem, our u is x minus 1, and therefore the u prime we need is just the number 1. We have an x here. We can't get rid of that x. I can't multiply by 1 over x to cancel that. I can only adjust by using a constant. So we need to introduce a different mechanism for solving this, and we're going to introduce what's called formal substitution. So if we look at and pick our u here, our next step is going to be to solve that for x. So I need to add 1, so I get x equals u plus 1. And I'm going to take the derivative of both sides. So the derivative, we get dx, and here derivative of u is du. So in this particular case, dx and du are the same thing. And we are going to now do a substitution. So we're going to use this to substitute for the x's. So I replace this x with u plus 1. And then under my radical, I replace this x with u plus 1. That's that x. I still have this minus 1. And I replace the dx with du. Now this can be simplified. Because I can subtract the 1, so I get the square root of u, and I'm going to write that as a fractional exponent. Now if we had this in earlier lessons when we were integrating, our step here to simplify this would be to distribute and turn this into polynomial form. So I have u times u to the 1/2. We add the exponents, we get u to the 3/2. and u to the 1/2 times 1 is u to the 1/2. And now we have an integral that is a basic integral. We can use our power rule to integrate this. We split this into the integral of each part using our properties of the integrals of sums. So here I'm going to get u to the 5/2 divided by 5/2. And here I get u to the 3/2 divided by 3/2 plus c. I need to simplify my complex fractions. And I could at this point do some GCS factoring. So I'm going to, my GCF, I need the common denominator of my fractions here, 15. And the least common divisor of our numerator is 2. And remember, I pick on my variable, I pick the smallest exponent. So this is our GCF. And we now divide each term here to get our leftovers. So I'm going to have 2/5 divided by 2/15 is 3. And I subtract my exponent, so I get u. And here I divide, I get 5. So we have our integral in simplest form, but we have an issue. Our original problem had x's in it, and our answer is in terms of u. So we need to convert our answer back in terms of x's, so now we have to do another substitution. So essentially we're going to unsubstitute, so we're going to be using here this and substitute back in. So every place we have a u, we're going to introduce x minus 1. So we have 2/15. And here I have 3 times x minus 1 plus 5. And my last part is going to be to simplify this. So I distribute my 3 and combine my like terms, so I get 3x. Here I have 3 times -1, so I have -3 plus 5 is plus 2. And now I have my answer back in terms of x, and we are complete. So this is our first example of integrating using formal substitution. Okay, let's look at our second example on formal substitution. So we have our next problem here. So first let's rewrite this into a u to the nth problem. So we have x times x plus 1 to the -2 power. If we were going to try using our shortcut, this would be our u. And our u prime then would be 1, and again this does not match. We have this extra x, so we need to go through our formal substitution method like we did in our last example. So if I solve this for x, we get x equals u minus 1, and if we take the derivative here, dx equals du. So let's do our substitution. So we have u minus 1 replacing this x. Now we need to replace this x, so we're going to have u minus 1 plus 1, which just becomes u. And then dx becomes du. Like in the previous example, we can integrate here by distributing. So we get the integral of u to the -1 minus u to the -2. Our power rule does not work for a -1 power, so let's rewrite this into a form we'll recognize. And now we can take the integral of each part. This uses our ln rule, so we get the integral of 1 over u is the ln of the absolute value of u. And here we use our power rule, so we add 1 to the exponent and divide by the new exponent. And we can simplify that as Now we have our integral simplified, but again, as in the last example, our answer is in terms of u, and since our original problem was in terms of x's, we want to get it back in terms of x, so we now need to essentially unsubstitute. So we're going to now use this equation here to substitute x plus 1 for all of the u's. So we have here ln of x plus 1 plus 1 over x plus 1 plus c. And we've now have our integral for this second example. Okay, we're now going to look at our third example for integration by substitution. So again, our first step is to put this into a power of, a term to the nth power. So we are going to convert our radical to a 1/2 exponent and then move that to the top. So we have here our negative 1/2. Now again, if I pick this as u, my u prime would be 2. I have this extra x, so we're going to have to go through the formal substitution. So u is going to be 2x plus 1. I need to solve that for x, so I have to subtract 1. And then I have to divide by 1/2. Let's go ahead and distribute that. And my dx then is going to equal 1/2 times du. So this is our first example where dx and du are not exactly the same. So let's do our substitution. So we have the integral of 1/2 u minus 1/2. Here we have u to the negative 1/2. And then we have here 1/2 times du, because we're replacing dx with this. We can do two things. We can bring this 1/2 and we can factor out a 1/2 here. So I'm going to bring that out to the front. So 1/2 times 1/2 is 1/4. So again, I brought this 1/2 out and I GCF factored out a 1/2 here and brought that outside the integral. Now we have u minus 1 times, let's go ahead and write that down. So we have u minus 1 times u to the negative 1/2. And we can use our distributive property. So, I'm sorry, we needed to add exponents here, so this is now a plus 1/2 power. And now we can integrate. So we have 1/4 times our integral, so we're going to use our power rule again. And we will fix our complex fractions, so we get here 1/4 times, so this is 2/3 u to the 3/2 minus 2 times u to the 1/2. And just because I like to, I'm going to GCF factor and simplify in here. Depending on what we're trying to accomplish, we might leave it in this format. Again, we still have to put it back in terms of x. So I'm going to factor out a GCF of 2/3 times u to the 1/2. And my leftovers, 2/3 divided by 2/3 is 1, and u to the 3/2 divided by u to the 1/2 is u. And here I have 2 divided by 2/3, which is 3. And the u's cancel out there. And my last step is I can multiply these two fractions, so I get a simplify here, so I get 1/6 times u to the 1/2 times u minus 3. And our final step is to put this back in terms of x, so I now need to use our substitution here. So I have here 1/6 times 2x plus 1, square root of that. And I'm going to replace this u with 2x plus 1. And I now have the minus 3, so I get 2x minus 2. And I can factor a 2 out of this. And when I do that, I will be, so if we factor this 2 out, I've got a 2 here. So I end up with 1/3. And we have 2x plus 1 to the 1/2 power times x minus 1 plus c. And we now have our final answer. So a lot of this work from in here was doing GCF factoring that we've done many times going back to the beginning of the year. Down here we have unsubstituted, put it back in terms of x, and I was able to do some additional GCF factoring to simplify. And again, the beginning of our problem, the key part here is to select u. In this case, and there are examples, I'm trying to match and use the rule u to the nth power, so we're going to pick the quantity that's in the parentheses as our u. We have to solve that for x so that we can then figure out the value of dx so that we can substitute. Many times dx and du are the same thing, but they don't need to be. So I hope this helps you, and good luck with your integration by substitution.